Okay, so first question, it says, PJ likes to ride his bike around the block. If he rides out of his house west, I'm gonna put west because that's a direction and that might help us with our velocity. The sidewalk circles his block and brings him back to his doorstep 0.35 miles later. Okay, so it circles the block and brings him back. Find his distance and displacement. And the instructions, I should have read the instructions first. It says, answer the following questions, sketch a picture before solving, and make sure to show all work. You may need a separate sheet of paper. Okay, so if I were to sketch a picture of this, and anytime you're not sure what's happening, you should always sketch a picture, but if it tells you to, you definitely should. So if this is, I'm just gonna sketch out, this is his house, right? And it says the sidewalk circles his block. Okay, so that means that it's probably gonna be either like actual circle, like a roundabout almost, or it could be like in a like rectangular shape, whatever it is. We don't really care about the shape. Whatever happens, that sidewalk circles around his house, okay, and brings him back to his door. Okay, it's like a loop-de-loop. And it says that's 0.35 miles later. So if he's going west, which direction is west? So north, east, south, west. If those are our cardinal directions, I always just remember that that is Nezwa. That's how I remembered it, going clockwise. So if he's going west, he's starting at his house going to the left, right? Or what we're going to call the left. He starts off going this way and he goes all the way around 0.35 miles. Okay. So the question is, what is his distance? So what is his distance going to be that he traveled? What's going to be his distance that he traveled? Not everyone at once. It's almost so easy that it's scary to say. What's the distance that he traveled? What's the distance that he traveled? What do you think? What is it? Say it. Yeah, it's 0.35 miles, right? That's how far he traveled. Good. It tells him right there how far he went. He went 0.35 miles. So if he were trying to track his distance for cross country or compare to like what his Apple Watch said, how far he went, they would put 0.35 miles would be his distance. Good. Okay, so now, give me a second. Let's talk about displacement. And I want to make sure I'm doing this the way they want me to. Yeah, okay. So now, displacement, the direction matters. And that's why I'm going to tell you what the displacement is, and then we're going to talk about why it is what it is, okay? The displacement, I'm going to say, was 0 miles. Okay? I'm going to say the displacement was 0 miles. Okay, so what does that mean is true about displacement? It's not just a positive 0.35 or a negative 0.35. What matters as far as displacement then? If I tell you that the displacement is 0, it's because he started and ended at the same place. So displacement, where you start and where you end, is the only thing that you take into account. Okay, so since he started and ended at the same place, his displacement is going to be 0. Okay? Okay, good. And I'm just going to write that out to the side because I'm going to put B/C for because He started and ended same place. That way, if I forget why it was 0, I've got it written down, okay? Okay, next one. Nicole parks her car at Target and walks 150 feet north to get to the store. Okay, so we're supposed to draw a picture, right? North on my paper is like up. So she parks her car at Target and 150. So here's gonna be, I'm gonna sketch out a car. Don't judge my car. Okay, she parks her car and then she goes 150 feet north to Target. Okay, so she goes 150 feet north to Target. Okay. Then it says on her way back to her car, she walks 50 feet before pausing when she sees a sign for discounted iced coffee at Starbucks. I would pause for that too. So she walks 50 feet before pausing, and she's headed back to her car. So that means she's headed back the other direction, right? So I'm just gonna draw a little arrow back the other way, and I'm gonna put 50 feet back the other way. Find out her distance and her displacement. So basically, she's decided Starbucks is more important than getting to her car, and she's left there, okay, in the middle, 50 feet down. Okay, so what is the total distance that she traveled? What's going to be the total distance that she traveled here? Yeah, good. The total distance, thank you, that she traveled, we're just going to add up all the things that she traveled. She traveled 150 feet to start off with, right? Plus 50 feet. So her distance, you were right the first time, her distance is 200 feet, because we're just going to add those up. And then you said the second one was what? You said the first one was 200, right? Okay. But didn't you just say 100 after that? Oh, just kidding. Okay. JK. Okay, so that's her distance, 200 feet. We just add them all together. That's how far she walked if you were trying to figure out her amount that she traveled. Now, displacement, that's like saying how far did she go from the original place that she started? Okay, so she originally starts at her car. She goes 150 feet. She backtracks 50 feet. How far in total did she go from her car, from her starting place? Good. She went 100 total from her starting place. She's 100 feet from her car. Okay, so to get that, if you want to write it out math-wise, you could do 150 feet. That's how much she traveled towards Target, minus the 50 feet that she traveled away from Target, minus the 50 feet that she traveled away from Target. That means her total distance from her starting place, which was her car, is 100 feet. And she's 100 feet from her car. Okay. Cool. So the formulas I gave you at the top, you definitely don't need on this. I thought you were going to do harder problems. That's evidently the next page. So keep a hold of those formulas for the next page, okay? Okay. Let's do another one. Maria is trying to meet her friends at the pool, but construction is blocking her path from the parking lot directly to the pool. Because of this, she has to walk 20 feet north. Okay, so she's in the parking lot. Here's her car. Okay. She has to walk 20 feet north. 20 feet north, that's up, right? North is up. Okay, 35 feet east. So then she goes this way, 35 feet. And I went to the right because I drew out my cardinal directions up here. So that's like east. And then 20 feet south. So I'm going to go back this way 20 feet. That's south. to get to the pool. And now she's finally at the pool. Okay, find her distance and displacement. Okay, so her distance, how far did she travel in total? What do we have to add up to find her distance? Distance is the easiest one. Yeah, the total of all of them. So you do 20 feet plus 35 feet, which you already did in your head, plus 20 feet. What's 20 plus 35? What's 20 plus 35? 55. Plus another 20 makes that total, good, 75 feet. So her distance is 75 feet. Now her displacement. The displacement is asking how far from her original starting place is she? So this is where we're going to have to sort of do a little bit of extra thinking in math. So luckily she sort of made a rectangle when she did this, right? It makes a nice perfect rectangle. So really from her car to where she's at would be like this arrow right here. So we need to figure out how long that arrow is. Well, if she went up 20, right 35, and back 20, how long does this arrow have to be for that to be that perfect rectangle? If this side is 35, what's this side? It's 35 as well, right? So the displacement, her displacement is going to be 35 feet. Oh my gosh, I just wrote that wrong. 35 feet. And which direction is that from where she started? So she started here, she's 35 feet this way. What direction is that? North, east, south, or west? Remember, your cardinal directions are north, east, south, and west. So in relation to where she started, did she end up north, east, south, or west of where she started? So if she ended up south of where she started, she'd be down here. She started here. So did she end up north of where she started, east of where she started, south of where she started, or west of where she started? East. Yeah, she ended up east of where she started, right? So that's 35 feet east. And I should have put directions on these other ones. I was lazy. This one was 200 feet, and that was up for the last one. Sorry, I forgot to put the directions. This one was displacement was 100 feet from car, so that was north of car, right? This one you ended up back at the same thing, so it wasn't in any direction. Okay. Let's do another one. Mally loves to make herself dizzy. She spins around in place 7 times before falling down right where she was standing. Find her distance and displacement. Okay, so if she's standing in place, I'm just going to draw a person standing in place, right? And she just keeps spinning in the same place. Has she gone any distance from where she started? No, she hasn't gone any distance from where she started, right? She's staying in that same place. So her distance in this case is 0. And we can put any units we wanted. Miles, feet, whatever. I'm just going to leave it as 0. Okay. And has she moved any place from her original starting place for displacement to happen? No, she hasn't. So her displacement for this is also going to be 0. She hasn't increased her step count by going farther away, and she didn't end up anything different from where she started. So that means her distance and her displacement is both 0. Okay. Next one. Stefan has to drive 8 miles south and 3 miles, 8 miles south and 3 miles east to get to work. find his distance and displacement. So Stefan, I'm just gonna put a stick figure. He's going, I guess I probably should have put a car because he's driving, but whatever. He goes 8 miles south, that's like down, right? So that's 8 miles south. And then 3 minutes east. East is like to the right. Or sorry, 3 miles east. So that's gonna be like 3 miles there. And it wants us to find his distance and displacement. Okay, so his distance. How far has he driven total? Good. He's driven 11 miles. All he did to get that was he did 8 miles plus 3 miles, and that's 11 miles. Good. Okay, now his displacement, we're going to have to figure out mathematically. Okay, so if he starts here and ends here, his displacement, we want to find this this length of that triangle where I drew it in pencil, okay? And this is where having paper might help you out. I'm gonna draw that triangle over here to the side a little bigger so that I can show you the math. Okay, so I'm just gonna sketch it out to the side. You don't need to, but I'm just doing this so that you guys can see better what it looks like. So triangles here, okay? This one is 8, this is 3, and we're trying to find this missing side. That's what I'm gonna call like X. Okay, this is where, in your notes, the Pythagorean theorem comes in handy. Do you guys remember the Pythagorean theorem? Okay, I see heads nodding, good. Okay, so the Pythagorean theorem is a squared plus b squared equals c squared. That's where A and B have to be the 2 legs. The legs are the things that are next to the 90-degree angle. That's what this little box means, is 90 degrees. Okay, so that has to be the 2 legs. And this over here, this longest side, the hypotenuse, that has to be your C. Okay, so we're just gonna plug stuff in and do a little bit of math. So I'm gonna put 8 in for either A or B, it doesn't matter which one it's in for. And then I'm gonna put 3 in for A or B, so I'm gonna get 8 squared plus 3 squared equals, and my C is my hypotenuse, so that's like my X here, so equals X squared. Okay, so now let's do our squaring. I always have calculators up here and over by the door if you need a calculator, but I think we can do this one in our head. 8 squared is 8 times 8. What's 8 times 8? Good, 64. If you can't remember that, remember I ate till I got sick on the floor. 8 times 8 is 64, okay? Okay, what is 3 times 3? 9, good. So we have 64 plus 9 equals X squared. Okay, cool. What is 64 plus 9? What's 64 plus 10? 64 plus 10 would be 74. So plus 9 is 1 less than that. So it's going to be 73. So I have 73 equals, oop, I didn't mean to put a plus sign, equals X squared. Okay, we need to get rid of the squared. How do we undo squaring? What's the opposite of squaring? You wanna know? Do you guys know what that symbol is? It's the square root. So to undo squaring, its opposite or inverse is square root. So I'm just gonna square root both sides. So when I square root both sides, I'll end up getting the square root of 73 equals X. Okay? I don't know what the square root of 73 is off the top of my head. While I'm jotting this out, can someone put that into one of your fancy calculators, the square root of 73? Because what we just found out was the length of this distance that's been traveled. So I'm going to put the displacement. Yeah, fill out a pass. Okay. The displacement, oop, I'm zooming in too far. The displacement for this is going to be, what was the square root of 73? I think I'm cheating and looking at the answer key because I don't want to have to type it in. But I think it's going to be 8.54. If you guys type that in and that's not what it is, you need to let me know. Okay. And now we need to put a direction to that. So, thank you. Our direction, if he started, hold on, let me look at a picture here. If he started here and he's going down and to the right, that's two directions almost, right? This downward direction, what is that on our, that's south, good. And then what direction is this? East. So that's 8.54 miles southeast. I'm just gonna put SE for southeast. Okay, so recap. We found the distance by adding up all the places he went, basically. The displacement, though, we recognized that it was gonna be formed by a triangle. So I sketched it out to the side, put what we knew. We knew the two legs of the triangle. The legs are what's next to the 90-degree angle, but we didn't know the hypotenuse. The hypotenuse is always the longest side, the one that's across from the 90-degree angle. So, bless you. So we had to put that hypotenuse in for our C, and we put the two legs in for A and B, and then we solve for that missing hypotenuse. Good. Thank you. Okay, let's do another one. By the way, if you think you know what you're doing and you don't need me anymore, feel free to ignore me and go ahead and work through these. Notice that the instructions said to sketch a picture before solving and make sure you show all your work. So make sure you do that. If you need a separate sheet of paper, please, by all means, grab a separate sheet of paper and attach it to this. I always have paper over there by the window, okay? Okay, let's do another one. Hey, people with your heads down, can you wakey, wakey, eggs and bakey? Can you tap him so he wakes up, please? Because I can't say his name and record this, because then I can't post it. Okay. Oh, there he is. Okay, he's awake. Okay, next one. Kai swims for the school swim team. He specializes in a backstroke event where he has to swim the 50-meter length of the pool 3 times. So he has to 50-meter length of the pool 3 times. Find his distance and his displacement. So if he's swimming, let's see here. I'm just gonna draw it from left to right to make it easier to see. So I'm gonna sketch out my little dude. Here's my little dude swimming. His legs are flopping behind him. His arms are out front. He's swimming, right? Okay, he's doing the 50-meter length of the pool. So he goes this way, that's 50, right? That's 1 time across the pool, and he swims it 3 times. So then instead of getting out and walking back, he just swims back, right? So that would be his second time, would also be 50, just in the other direction. And then his third time is 50 back that way. So he goes back and forth, and he goes forward 50, backward 50, forward 50. And that's the units for that is meters. Okay, find his distance and his displacement. So what is his distance in this? Good, his distance is 150 meters. How did you do that? What'd you do? Yeah, he realized that he went 50 meters 3 times. So he just did 3 times 50. Or you could have done 50 plus 50 plus 50. Either way works. So his distance is going to be 100. I'm going to put that in parentheses too. So is 150 meters. Good, because he went 50 meters 3 times. Okay, so now to find his displacement, how can we figure out what his displacement is? If he started here and he ended up, this is his ending spot, right? He ended up over here 50 meters from where he started. What's his displacement then? Good, his displacement is going to be 50 then. So his displacement is going to be 50 meters. And I'm going to write, since we don't know if it's northeast, south, or west, I'm just gonna write 50 meters away from the side he started on. Okay, because I don't know whether it was like northeast, south, or west, or left or right. I just know it's the opposite side of the pool. So he's 50 meters away from the side he started on. Okay, good. Okay, let's do number 7. On the way home from school, Taylor's car runs out of gas. He has to walk 25 meters north, 10 meters west in order to reach the nearest gas station. Find his distance traveled and his displacement from the car. Okay, so he runs out of gas. Okay, so, and he leaves his car where it's at. Okay, so his car, I'm just gonna put his dead car and stick it there. And then he goes 25 meters north. So he goes 25 meters, and that direction's north, so I'm putting that as up. And then 10 meters west, so that's like left on my paper. So then he goes this way 10 meters. And it says we want to find his distance and his displacement. So the easy one is his distance. How can we figure out his distance? Good, we do the 10 meters and the 25 meters. That's all the stuff he traveled. Okay. So that's going to be 35 meters, right? 10 plus 25 is 35. Okay, now his displacement, notice again, he ended up, if you were to draw this out, it would make a nice triangle, right? So we're going to have to Pythagorean theorem that to figure out where he ended up. So I'm just going to sketch that out to the side again so that I can do it a little better. So I'm just going to sketch out the triangle over here. That will help me to process what's happening. Okay, so that's like his triangle. This one was like 25. This was like 10. And I'm trying to find out this side across from the 90-degree angle. We assume that when he turned and went directly west, that would make it a 90-degree angle, right? Okay, so if I write out my Pythagorean theorem, which one of these, the 10, the 25, or the x is my hypotenuse? Which one is going to be my c? Which one's that longest side? The x, good. That x is going to be like my c. That's the one that matters. You have to make sure that longest side, the side that's across from the 90-degree angle, that has to go in for your c. It doesn't matter which one of these go in for A and which one goes in for B, as long as these other ones are on the left side then. So I'm just going to go ahead and put the 10 in for A and the 25 in for B. If you did the opposite, that's okay. Okay, what is 10 times 10? What is 10 times 10? 100, good. And then 25 times 25, what is that? Is that 225? I used to have all of these memorized. No, I totally lied to you. 25 times 25, what is that gonna be? It's 625. I don't know why I was thinking 225. Okay. Okay, so cool. Equals x squared. I'm gonna run out of space. I'm gonna just keep working down in this bottom chunk because I'm out of space. What's 100 plus 625? Good, it's 725. And then to undo squaring, we're gonna square root both sides. That undoes this squared. So we're gonna type the square root of 725 into our calculator. Oop, that undid our squaring. So let's see here, the square root of 725. Did anyone type that in? What is it? 26, he says it's 26, I believe him. Okay, so he said 26 is gonna equal our x. So that's gonna be our displacement then. Our displacement, oop, you can't see what I'm doing. Sorry. Our displacement is gonna be that 26 meters. And that's north and west of where we started, right? So that's going to be northwest. North because he went this way first and then west. So that means it's northwest of where he started. Okay, good. Fantastic. Thank you guys. Hey, if you guys will try that challenge problem tonight, everyone needs to try it at some point. If you get it and get the right answer, I'll give you extra credit though. Okay? We'll start with that first thing tomorrow.